I hope everybody is enjoying lunch. I just wanted to gather the group back together, and you will have other times to network. A reminder, there is a reception tonight, so we will have plenty of time for mingling with each other. I'd like to do a little bit of an update for you all, and congratulations to everybody's participation as well. Just to give you a little insight of who's here today, there are 530 people registered at this event. So if you see people wandering around, there's a whole lot of us at this event. And I wanted to give a special thank you to the students. Of those, that's 250 students that have registered to be here today, representing 8 different universities. So thank you for everybody who traveled from other universities to come to this event. There are 90 companies that are represented at this event and 30 different Illinois departments and units. So it's a great example that big data is a topic that spans many, and it has a lot of interest because it impacts a lot of industries, organizations, nonprofits, and other areas of application and research. So thank you for everybody who's interested in this topic. 5 years running, it hasn't slowed down, it only continues to grow. I also wanted to give a special thanks to those that are here for MWIN. We are really privileged to have the National Science Foundation award us as part of a node across the Midwest. So Jed, Taylor, Harley, and the startups that you're mentoring, if you're in the room, if you want to give a quick stand up, I'll say these are folks that are emerging, thinking about doing startup companies or have new startups. And if you've previously gone through I-Corps, I would like to join you to stand with this group of those that are going out, figuring out where there's customer demand for new products, and figuring out where new startup opportunities may emerge from universities. So all those associated with either MWIN or I-Corps, if you could please stand briefly. I think there are some that have been through before that didn't stand on that note. But anyway, those that are new, I also wanted to specifically call out that at 3:20 we will have a startup pitch panel. And if you want to hear about 4 new emerging companies and give them feedback, also you can do that. On your table is a little cheat sheet about who will be doing that today. So the companies will be SIFT, Polar, Simultac, and Healthy Brain AI. So join them for their startup pitches later this afternoon, and if you can't and want to engage with them in some other way, there's a little bit about what their approach will be. It's next my pleasure to introduce our lunch speaker today, and I'm really excited to have Joe Jablonski join us for this event, and I thought I'd give you a little bit of background information about him. So he's, as it says in your program, the co-founder and CTO of a fast-growing company called Ocient. But he has also been in the Chicago tech industry for a long time. This company that he's working with is exciting to us, I think, for today's event because they're enabling sophisticated users of data to handle massive amounts of information in real time for making decisions. And that's something that's aspirational to, I think, many companies that are trying to move in that direction. But I've had the pleasure to know Joe for, I think, about 7 years, as I was thinking back of when we had first had interactions through the ITA, an organization that we both have had the privilege to serve on the board together for, and that helps fast-growing companies in the growth stage of their business. And through those experiences, I've gotten to know Joe as a software engineer, as an innovator, and a thought leader in the industry. He's somebody who figures out where there's a problem, how to solve it, and really values, I think, those that can contribute in meaningful and difficult challenges that exist in the industry. I've also gotten to recognize what a big champion Joe is of the University of Illinois at Urbana-Champaign. So if you talk to Joe, he will talk to you about his Illini experience, and he will talk to you about how he wants lots of our students to come join him, and whatever it is that he's doing at the current moment, but right now, that's about hiring a lot of students that have joined Ocient as well. He builds great companies, attacks hard challenges, and the last company that he was able to do that with was CleverSafe before this, that sold to IBM for $1.3 billion and had acquired, as one of the companies in the US, the most patents, as certainly of a smaller and emerging company that did so with scientific minds, many of which came from the Illinois engineering community. He now is working on this new company, And he is, as I said, I think you won't find a new, more proud and more passionate alum about engineering talent, about the opportunities that you can do when you find smart people, and about how we can work together in many cases across the tech industry in Illinois. So please join me in welcoming Joe Jablonski.
Hi, thank you for having me this afternoon. Yeah, I went to school here, graduated in '93. Interesting fact about Ocient, as we get the projector up here, is half of our company went to U of I. We hire a lot of computer scientists, and we're keeping that going. So I think right now we're attempting to hire 30 to 40 new recruits out of colleges, and probably 25 to 30 of them will come from Champaign. So yeah, it's really great. So it's a testament to everyone here, the professors, everything, how great your students are. So cool. So when I was asked to keynote today, I really thought about what I would want to know about big data. And I always say, I sit in the audience of these things a lot, and I see things that don't really relate well to me. So I always try to give the speech that I would want to see. So the speech, the topic I came up with, what I would like to hear is, what is big data, and really what is the future of it over the next 10 years? So I went into our research partners, got a lot of factual data, a lot of quantitative data, and then what I'm going to present today is what is the future of big data, and what are the trends, what are the forecasts, what is going to generate data, where is data going to be stored over the next 10 years. So a little bit about me. As I said, I'm an alum. Did it not go? Is someone here that can, I hit down and it did not go very well. So a little bit about me. The slide will catch up in a little bit. Yeah, so I'm a UC alum, graduated in '93. I've started and sold 3 different companies. I've been a tech entrepreneur pretty much when I was about 5 years out of college. I really have been an entrepreneur since then. And now I'm the co-founder and CTO of Ocient. A little bit about Ocient is we're building a database platform to hold the world's largest data sets. So what does that mean? From quadrillions of rows to hundreds of petabytes of data, we're designing a data platform that can hold that quantity of data and traverse trillions of rows per second. We're doing that primarily on a type of drive called an NVMe drive. And in designing, what we're attempting to do is design the fastest data platform in existence. I live in Chicago with my wife and 3 kids. My wife also went to school here. We met here. So yeah, I'm a big fan of U of I. So the first thing we'll talk about is what is data. I'll use some terms today. What I found out is a lot of people don't know the terms that I use. So it really starts, everyone knows what a megabyte is, what a gigabyte is. You go to a petabyte, then you go to an exabyte, which is 1,000 petabytes, a petabyte being 1,000 terabytes. And then really, you go to a zettabyte. And a zettabyte is 1,000 exabytes. So we'll talk about data in terms of zettabytes. We used to talk about data in terms of petabytes. Then we went to exabytes, and now we're introducing zettabytes as really our data term. So the first thing is, what is big data and what is the trend for data? So when I was going through the data, this is primarily all from IDC, which is a big research company. And the first thing I did was go through their data from 2009 to 2007. And I remember when I saw this slide in 2009, and they talked about what would big data be in 2009. And I was like, wow, data's going to grow that much. This is crazy. But I thought I'd bring this because it was exactly accurate. And so when you look at 2009 data and say, wow, they were really great. But in 2009, you see the growth that they projected. And in this year, in 2016, they projected, if you see the quantity, roughly 16 zettabytes. And if you go to the next table and you see where it is, and the growth curve, we're right at 16 zettabytes this is how much data is stored in databases, in disk drives, how much storage is accumulated every year. And right now, we're about 16.1 zettabytes. In the next 10 years, so by 2025, the prediction will be 163 zettabytes per year of data being stored, which means really a 10 times growth in the quantity of data being stored. That's really an amazing growth rate still, when you talk about the magnitude of what those numbers are. So I guess the summary of this is if you look at the trend over the last 7 years, the trend is continuing for data to continually exponentially grow. And so that's really a great reason. It's a great reason to be at this conference. It's a great reason to look at this whole topic. So you start talking about where is the data being generated? What is generating this data? Where is it coming from? And what you start to see is really different trends here of what's happening. More and more data, the pink part is really from the core. I'm sorry, that didn't show up too well. The pink part is the red part's from the core. That's core systems, core infrastructure. The middle part is from servers, from edge devices. And then the third part is really from home PCs, phones, cameras, things like that. So what is interesting, what I find interesting in this trend is more and more data as a percentage of the data being generated is going to be generated by servers going forward. So things like logs, things like core infrastructure are in that red part across the top. Core infrastructure, by IDC's definition, is really being defined as networking infrastructure. So this is all the data coming off Verizon cell phone networks, all the data coming off our smart grids. All of that is just going to start generating more and more data as a percentage of the data being made. And then we look at where data is being stored over time, what the trend is of where data is being stored. A little bit more on mobile, basically mobile devices on the top. They'll get a little bit bigger. We'll put a little bit more storage into our mobile devices. They're really a caching device for pictures and video for the most part. DVRs, really, if you look at in 2017, the percentage of storage in the world, about half of it's DVRs right now. And that trend is going to be basically, those are going to shrink. They're going to get smaller and smaller. And then PCs, which is the blue part of this, is where PC storage is happening. That's also shrinks. As we don't store our media, as we get rid of our video, as we get rid of our photos, as all that moves into the cloud, more and more of it moves off PCs, and then everything moves into the enterprise. So the enterprise, cloud storage, enterprise storage, that all gets bigger and bigger. And this is what we'd expect. Some of the interesting topics here are data criticality. So this is the criticality of data. And what this is defined as is how important is this to run our lives? If you think about our lives 10, 15 years ago, you didn't have the data, you were able to run your life, things worked. There's more and more. I was driving down today, stopped to get gas, the credit card machine was down. I couldn't use my credit card as I tried to pump gas. And how much of an experience it was where I couldn't walk into a gas station, just quickly swipe my credit card, pump gas, and leave. I had to go inside and see everything. And how materially that affected how much longer that transaction, everything was down. This is really what we talk about when we talk about data criticality. How many times data is going to affect our lives? How many interactions we're going to have with data? And how important is it going to be within our lives? And really what you see here more and more, data criticality is going to be more and more important. From critically important, things like healthcare, access to medical records, to not as important. And then we look at what's generating this data, or where data is being generated. So the bottom orange part is entertainment. Movies, video, music, still generating a large portion, but not quite as high as it used to be. And then non-entertainment video. So if you look at by 2025, half of our big data, half of our storage will be just basically video. Right now, that's a higher percentage of how much is video. But what really grows, and these are the important things, I think this is what we always speak about when we talk about big data, are really the next two categories. And that's embedded data and productivity data. Productivity data being files, server log files, things generated from servers, and then really embedded. That's the IoT world. So when you look at those trends of where the data is going to be generated by 2025, what we really see here is this tremendous need to store and analyze this new type of data. And that's really the IoT data, the data coming off of sensors, coming off other servers, server log files, things like that. And how much growth is really there. And then the growing need for what we call ultra-large databases. So over time, the number of databases that contain over 1 trillion rows grows drastically. Then the number of databases between a trillion and a quadrillion starts to grow. And then we start to see the rise to the quadrillion row database systems. So basically what this says, our data is growing massively, our tools need to change, and our tools are going to be able to need to be able to handle analysis at this level. So it's a pretty exciting time. And you'll see from 2016 to 2025, the number of quadrillion row databases is going to grow 50 times. And all this is from the rise of embedded data. Embedded systems, all the types of devices, cameras, security readers, smart meters, automobiles. Right now, if you look to see what you collect from, it's rather limited. But in the next 5 years, 10 years, we'll all own a car connected to a wireless network. It'll have 1,000 sensors on it. We'll sample that data at 1 kilohertz. So, I mean, every second we're going to be generating 1 million data points off our cars. This is going to be the world we live in. If anyone's been to Disney World recently, you wear the smart bands. The amount of data they collect off that to optimize their parks is just amazing. And it's just like, and everything's going to be like that in the future. And so our interaction with data is really going to increase. So right now, the number of interaction data points we have per day in about 2015, so we have about 218 interactions with data. That's what a per person has per day with their data. So we, on average, interact with data in our lives. So what does this mean? When we turn on Netflix and it comes up with a cue to suggest what we watch, that's an interaction with data. When I see anything on the internet that serves an ad to me, that's an interaction with data. When I look to buy something on Amazon and it interacts with me, that's an interaction with data. So right now, on average, we interact with data 218 times a day. By 2025, this is going to change massively. This is probably the single most important slide that I think I have in this deck. And that is, we're going to see a 22 times increase in the number of times we interact with data. So when you look at, if a human interacts with data almost 5,000 times a day, that means roughly every 15 seconds of our life, we're going to be interacting with some sort of data. From whether it be the lighting in the room, the air conditioning, everything's going to be analyzing data and affecting our lives. It's going to be acting upon our lives. It's going to be the response to IoT. The first phase of IoT is going to be collecting all the data. The next phase is analysis. And then the final phase is actually controlling things in our lives. So this is the projection. This is what we think is going to happen. But think about a world in which you live in which machines are going to affect your life every 15 seconds. It's a pretty amazing world. One of the things that I've always wanted is food to just show up at my house. I think the problem of me having to go to the store, select what I want, go through a grocery store checkout, bring it home, it all seems absolutely a waste of time to me. Think about a world in which you just have it delivered to your house because they know everything what you want. They know what you've eaten in the last week. They know that my daughters aren't going to be home or my wife's going to be home. They know exactly how many people are going to be at my house, and then they drop off a meal for me to cook. This is the world we're going to live in. This is the world we're going to live in the next 15 to 20 years. This is the kind of change that's happening. I think there's so many entrepreneurial opportunities around these interactions, whether it be from the tools to do analysis or driving this interactive change. There's just tremendous opportunity around this change. I've been an entrepreneur for a long time, and what we always look for when we start a company, when we work with a company, is really just tremendous change happening. It's almost impossible to start a company. It's almost impossible to be successful without changes like this happening. So if you're in this field, if you're looking to start a company, it's really the optimal time to do that. So this is interesting from as being the CTO and the really geeky guy. I really start to look at how does this affect hardware? How does this affect media? So I grabbed the data for what type of media everything's being stored on. So the DRAM is the sliver across the top. DRAM gets a little bit bigger, our caching layers get a little bit bigger, but for the most part it stays proportional. Optical pretty much goes away. CD-ROMs, DVDs pretty much go away. Tape, still in existence, still shrinks a little bit, but tape is still very good for archival, especially for long-term storage. But what gets big is flash. If you see where flash was in 2010 here, and as it grows, it really grows much bigger. And then the blue part is the spinning disk hard disk. So really what you start to see is a segmentation of the industry, saying video, photos, music, all that's going to be stored on spinning disk, all these large objects. You're going to store that in spinning disk. Everything else will be stored in flash. And then you'll have a small amount of caching layer in DRAM. So that's the world that we're going to see from a technology perspective. And I figured I'd throw my slide up of what I look at every day, the way I analyze our technology stack, of what DRAM costs, what all the different layers of technology cost. So if you start at the top, you go DDR4 DRAM, it's about $12 a gigabyte. 3D XPoint is it's the new media coming out from Intel. It's going to be a DDR4 form factor, due out next year. They're projecting that to be about half a DRAM, so that's $6 a gigabyte. 3D XPoint, and 3D XPoint is a new type of physical substrate coming out from Intel. It's out in the NVMe form factor that plugs right into PCI. You can buy it. It's about $3 a gigabyte in that form factor. And then you have the different types of NAND, MLC NAND, 3D NAND. MLC NAND right now is about 80 cents a gigabyte. 3D NAND, 3D TLC NAND, where they put 3 charge layers within a single NAND chip, and then build it in a 3-dimensional fashion in the manufacturing, is about 60 cents a gigabyte. And then spinning disk is about 4 cents a gigabyte. I see this trend continuing. Memory has been on the same trend for the last 40 years. So what happens with memory is it pretty much gets cut in half in price every 5 years. That should continue. But what's really interesting is what's happening in the 3D TLC NAND market. You're seeing 3 companies really get big in this space, like really big. Samsung, Intel, and then the recent joint venture between Toshiba and a bunch of other companies. Apple bought a big part of Toshiba, and that joint venture has really started to become really big. So you have 3 companies investing tens to hundreds of billions of dollars into 3D TLC NAND manufacturing. And that price is going to get driven down. So that 3D TLC NAND, I suspect we'll see that really drop out in price, and we'll start to see solid-state drives really come close to the price of spinning disk over the next 10 years. It's what I firmly believe will happen, especially with the lower endurance NAND. We'll see that start hitting the price parity of spinning disk. So some of the conclusions. Data growth is growing massively, especially in the area of IoT and the connected world. Video, we've digitized our world. That was the expansive growth of video. Video is going to continue to grow as we move from 1080p to 4K to 8K video. We'll see linear increases in video. But the transition from analog to video pretty much already happened. Same thing with music, and we'll continue with those trends. But they're not going to change massively. What is going to change massively is the amount of data coming from the connected world. The number of human interactions is what I think is going to be amazing in the next 10 years. As we move to the interaction every 18 seconds, our world is going to be manipulated by data. The world around us is going to be manipulated by data. And the interactions are real time. The tools, the platforms we build, how we interact with data is going to need to take that data, interact in real time, and affect our world in real time. So what does that mean? You know, roughly in seconds. Queries need to run in seconds, not hours. So for those of you that have worked a lot on big data systems, Hadoop, Cassandra, a lot of these tools, I've worked on almost all of them. We're used to seeing response times in hours, tens of minutes, double-digit minutes. The world's going to need response times on these quadrillion row data sets in sub-seconds. And that's the trend that we've built our company around. That's what we firmly believe, and that's what we're attempting to do. And that's the world that I think will happen in the next 10 years. So, and then our tools fundamentally need to change. Well, that's what I prepared today, and I greatly appreciate everyone listening. If anyone has any questions, I'm more than willing to entertain any questions.
Questions, and we will bring the mic around so that it's included in the recording. Yep.
So I was curious if you have any insight with all the availability of data. I recognize that all data has the potential to be analyzed in some fashion, even video with all the optical recognition techniques. However, do you have some insight on how much of that data would be or have the highest potential to be analyzed? Because some of the entertainment data, the video data, that's probably a pretty low opportunity there. So do you have some insight on how much of that data is really good opportunity for analysts?
Yeah, you know, so I look at it, the way I look at the world is structured data, semi-structured data, and unstructured data. And that's what I call the amount of structure to it, that is how easy is it to analyze. I look at video, a little bit harder to analyze. If I'm trying to analyze video, it takes a lot more processing power to do that. Semi-structured data being something like email or text messages. You can do it, it's structured, but it still takes more raw processing. And then stuff in databases. Data, strongly typed, strongly structured data within databases just takes a lot less power. I think it's all over the place. I mean, is the reality. So if you see where the data comes from, I think you'll see the trends. I think you see it in video. You'll use a lot of deep learning neural network techniques that seem to be really good. When you start looking at more structured data, more of the clustering analysis, linear regression, straight off the data. If you look at the sources of the data, it kind of tells you the structure associated with it. IoT, things like that, I think is going to be really pretty easily analyzed. Where I think a lot of messy video when you're trying to determine things like find Joe in this picture. Actually, that's not that hard, but find like a blue car moving at this rate becomes a lot more difficult. But I think it's all over the place. But what you'll see is the growth of that IoT world that is easily analyzable will grow pretty massively.
Are there questions?
This is just what do you think about, because we are in an environment, university environment.
Yep.
And as you said, we are it's a transition from, for example, in many areas, from a skill-based management to a more, I would say, objective data. So what do you think the university, the learning, the careers will affect with all this data trend?
Yeah, I mean, I think, I thought about this a lot because we've been recruiting a lot on campuses, a variety of campuses, and we're seeing the students that are at the University of Illinois here, and they're frankly, we need to transition in a big way to having more fundamental skills across the group. This is something that's actually I'm pretty passionate about, and I think it happens at the grade school level. I have 3 daughters, and I've really taught them all from almost birth on how to program. We don't have enough engineers. So I'm on the board of the Illinois Technology Association with Laura, and I've run tech companies. I'm a CTO of Ocient. We're not even close to enough engineers. It's not even in the ballpark. The number of engineers that we need to have needs to go up by a factor of 50. I mean, we need to expand our university system enormously in this country in order to generate the people that are going to have the skills to do this, whether it be hardcore programmers, whether it be analysis, whether it be people that can set up systems like Hadoop and Cassandra and things like that. Our skills are so inadequate. I project there won't even be jobs for people that don't have these skills. I mean, I think the number of jobs that are going to be automated in the next 20 years is going to be astounding. I think we will see self-driving cars. I think we will see a lot of things that are going to take a large number of jobs away from in this country. And we need to retrain our workforce in a big way. I think at the grade school level, where my daughters are all right now, there's not a lot of attention paid to computer science. There's not a lot of attention paid to logic. And I think that needs to change rapidly. I think it needs to change today. We need to retool our grade systems in an enormous way. And I think that then you'll see more students capable of studying computer science if we retooled our grade school systems. And then you can see universities actually make that change. Does that answer your question? Is it?
Thanks.
Cool.
See another one?
So in 2025, at what point does the interaction with the data devalue your time? I mean, if you're in interaction with that much data, at what point does it override your daily activities?
Yeah, no, I have that. So the question was, by 2025, when we start having 4,000 interactions a day with data, or interactions every 15 seconds, at what point do you get a diminishing marginal return on those interactions? Is that essentially your question? So at what time does it start to become unimportant? I mean, that's, I wish I could project that myself. I think about a world in which decisions are made for me without me even thinking about it, and think about what that would be like, and it's hard for me to envision. I think I'm a little bit older, so I'm a little bit actually. I don't use as much technology as other people do, but I do see my daughters. I do see younger people in the way they use technology, and I think it's just going to change radically. I think the amount of interaction. I think. We start to see, like in our homes, just the start of we have thermostats that autocorrect without us using thermostats. All my lights going off in my house without me thinking about it anymore. It really is starting to happen, and I think that trend just continues more and more. And it's interesting because I don't even think about it anymore. But I think that trend will continue to happen. It's very difficult for me to personally think about all the ways it can happen. But as the data becomes, I truly do believe it will happen.
I don't see any other hands, so I think we're just going to say thank you,
Okay.
Joe, for
Thank you.
challenging us of the possible.